Right, so this is a word problem on quadratic equations, and the question is, uh, there's a field, so it's a rectangular field, so let me just draw that real quick. So let's suppose this is a rectangular field, and you want to create a walking track around it. So this is some place where people come in the morning for their morning walk, and you want to create a proper walking track for them, because otherwise in the rains it just gets all muddy and squishy. So you want to create a proper walking track around it. And what you're told is that the length of the field, right, which would be this, so the length of the field is 16 meters, and its width, which would be this, this is 10 meters. Now the walking track you want to create, which would be all of this, right? This has to be of constant width, which means that if it's this width d is constant throughout, so that means that this is also d. And you're going to pave this walking track with tiles, and tiles are bought by square area. So no matter what tiles you buy, so if you buy tiles for the bathroom or for the room, then tiles are sold by their area, and you have a budget, right? So you can't spend any amount of money, and your budget is enough to buy only 120 square meters of tile. So now the question is, how wide a track can you make around this field? So really what it comes down to, what will d be, small d be, so that you can create a walking track around this field and still stay within your budget, which allows you to only buy 120 square meters of track, of tiles, sorry. So how do we think about this? Well, this is an easy enough problem, and what we should do is, let's just label some corners. So the field is A, B, C, D, right? This is these points on the inside, and let the outside track be W, X, Y, Z. So the area of tile that you need, that you'll be using, area of tile that you'll be using is simply the area of WXYZ, which is this whole outside rectangle, minus the area of the field, which is ABCD, right? So this is how much tile you'll be using. Now the area of the field is simple enough. We know what its length is, which is 16 meters, and we know what its width is, which is 10 meters. So we know what the area of the field is. All that we need to do is find out what the area of this big rectangle on the outside is, WXYZ. So what would that be? Well, for that, for WXYZ, first of all we need the length. So what is the length of this field? This length would be this thing over here, right? So what would this length be equal to? Well, it would be at least 16 meters. So it will be 16 meters plus plus this width over here. So let me just clear up some. This has become a bit messy. So let me just see if I can clear some stuff over here for you to see. So it would be 16 meters plus this width, right? So this width was d, the small d that we had, so that much, and the same thing in this corner. So it will be this width over here. This would also be d, so plus another d, right? So the length would be 16 meters plus 2d. What about the width? Well, the width of this would be 10 meters plus, by the same logic, so the width would be here. So this is the width, right? This diagram's become a bit messy, but you got the 10 meters from here, and you will have d from here, that's extra, and another d over here. So another 2d from here. So the width would be 10 meters plus 2d, right? So the dimensions of wxyz are going to be 16 plus 2d meters by 10 meters plus 2d, and therefore its area is going to be equal to 16 plus 2d multiplied by 10 plus 2d, right? So the area of tiles that will be used is simply this expression, and this we know can be equal to only 120 square meters. So all that we need to do is just expand the left hand side first. So left hand side is going to be 16 times 10, that's 160, plus 16 times 2d, which is 32d, plus 2d times 10, which is 20d, plus 2d times 2d, which is 4d square, minus 160. And this has to be equal to 120, right? So the 160 cancel, so that's good. And what we are left with is 4d square plus 52d is equal to 120, right? So let me scroll down a bit. Now this whole thing, we can take 4 out, so this means 4 times d square plus 13d is equal to 120, and therefore if I take this 4 down over here, this becomes 30. So basically our equation is d square plus 13d is equal to 30, which implies d square plus 13d minus 30 is equal to 0. So now this is a simple quadratic equation, and all that we need to do is find its roots, which means we just need to find values of d. So this can be done in one of two ways. So one way is to say that d is going to be equal to minus b plus minus root b square minus 4ac by 2a, right? This will always work. This is the standard way of solving an equation. And the other way is to try to find factors, try to factorize this quadratic equation and then find out roots. So I'll just stick with this method, minus b plus minus root b square minus 4ac, this one, because it always works. So if we were to do that, then b is 13, so minus b would be minus 13, plus minus root b square, that's 13 square, that's 169, minus 4 times a is 1 times minus 30, that's 4ac, so c is minus 30. This whole thing divided by 2 times a, which is 1. So what we get is minus 13 plus minus under root 169, and minus 4 times minus 30 is plus 120. So plus 120, let me just scroll down, divided by 2, which is equal to minus 13 plus minus under root, so 169 plus 120 is 982. Okay, so that's 289, right, divided by 2. Now I can tell you that under root 289 is equal to 17, right? 289 is a perfect square. So what this means is that d is equal to minus 13 plus minus 17 divided by 2, which implies that d is equal to either minus 13 plus 17 divided by 2, or d is equal to minus 13 minus 17 divided by 2, right? And so this gives the value minus 13 plus 17 is 4, divided by 2 is 2, so 4 divided by 2 is 2, and this is minus 13 minus 17, that's minus 30, and that divided by 2 is equal to minus 15. So what we have is d is equal to 2 and minus 15, right? So these are the two values of d that we get. Well, a value of d less than 0 makes no sense, right? You're looking for the width of the track. So a value of d less than 0 just does not make sense. It might be mathematically correct, but you still have to interpret the result. And therefore the only value that does make sense is a value that's greater than 0. And that only leaves us with d equal to 2. So the answer to our question is, with the budget that's given, you can make a track 2 meters wide around this field. So the answer is, the width of the track will have to be 2 meters. So that was the question, and that's how it's done.